So here are our homework solutions for day 3.5. So we're given two equations, y equals x plus 7 and y equals negative x plus 5. So we need to find the intersection point, or the solution, to these two equations. The first thing we need to do is we need to make sure that they're in slope y-intercept form. And in this case, they are, which makes this a little bit easier for us. So what we do is we take a look at what is just to the right of the equal sign. So we've got x plus 7, and we've got negative x plus 5. If this is equal to y, and this is equal to y, then this part is equal to this part. So we could write something like x plus 7 equals negative x plus 5. Once we've done that, we'll collect our x terms on the left-hand side and our numbers on the right-hand side, giving us 2x equals negative 2, and that simplifies to a value of negative 1 for x. Now, once we have a value for x, we can take that value and we can plug it back in to either one of these equations up at the top. We use the first or the second equation and simply substitute negative 1 for x. So in this example, I've decided to use the first equation. So I simply take the negative 1, substitute it in for x, and I get y equals negative 1 plus 7, which gives me a value of 6. So my x value is negative 1, my y value is 6, my solution is negative 1, 6. This is the intersection point. And it doesn't ask for it, but if we wanted to, we could graph those two equations. And in this way, you can see visually that indeed the intersection point is at negative 1, 6. Question B, we're given two equations again. Again, they're both in slope y-intercept form, so we don't have to make any changes to the equation before we start comparing them. Y equals 2x minus 21, y equals negative 2x plus 3. Therefore, we can say 2x minus 21 equals negative 2x plus 3. Collect all our x terms on the one side and our numbers on the other side. Further simplify to give us a value of 6 for x. Once we have one of the variables, we can simply plug it back into either one of the equations to figure out what the other variable is. In this example, I've decided to use the second equation. So plug in 6 for x, gives me y equals negative 2 times 6 plus 3, gives me a value for y of negative 9, x equals 6, y equals negative 9. My solution is 6, negative 9. And again, if I wanted to, I could graph it. And when I graph these two equations, I can see that the lines intersect at the point 6, negative 9. Question C, two equations, y equals 2x plus 1 and y equals negative x minus 23. Set the right-hand sides equal to one another. It gives me 2x plus 1 equals negative x minus 23. I'll collect my x terms on the left-hand side and my numbers on the right-hand side. Gives me 3x equals negative 24. Further simplifying and solving for x gives me a final value for x of negative 8. Once I have a value for x, I can plug it back into the equations. I'll use the second equation this time. So plugging negative 8 in for x gives me y equals 2 times negative 8 plus 1. Slight correction here. I ended up using the first equation here. I plugged y equals 2 times negative 8 plus 1, giving me a value of negative 15 for y. I now have an x value of negative 8, a y value of negative 15. So there's my solution. And again, if I chose to graph these two equations, I could visually see that the lines intersect at the point negative 8, negative 15. Write a pair of equations to represent each situation and then solve the linear system using substitution. So we have two statements here. Malcolm is twice as old as Stephen, and the sum of their ages is 39. Now in these word problems, we need to declare a variable to represent what we're trying to find out. So we want to find out what the ages of Malcolm and Stephen are. So we can say let x be Stephen's age and let y be Malcolm's age. Now we're told that Malcolm is twice as old as Stephen. And we can represent this with the equation y equals 2x. Malcolm is twice as old as Stephen. Now we're also told that the sum of their ages is 39. So we can represent this statement with x plus y equals 39. So now we have two equations. The trouble with this equation is this is not yet in slope-intercept form. This is, so we're good with this, we can leave this, but we have to convert this from, well, this is actually in standard form. We need to convert this into slope-intercept form where it says y equals something. So to do that, we'll rewrite that second equation in slope-intercept form. And that will be equal to y equals negative x plus 39. We simply take this x here, we move it over to the other side where it becomes a negative x, and now we have an equation in slope-intercept form. So we have two equations in slope-intercept form. So we can say that 2x is equal to negative x plus 39. We'll collect all our x's on one side and our numbers on the other and solve for x, ending up with a final value of 13 for x. Once we have a value for x, we can substitute that value back into one of the equations and solve for y. So we'll use the first equation. It's a slightly simpler equation. And substitute 13 for x. Y equals 2 times 13. Y has a value of 26. So x equals 13. Y equals 26. Our solution is 1326. We could check our solution by plugging those values into either one of the equations. So if x is 13 and y is 26, we need to check whether this equals this. And as it happens, 39 does indeed equal 39. Left side equals right side. Once again, if we wanted to, we're not asked to do this, but we can just illustrate that it is an intersection by graphing these two equations, and we can see again that the two lines intersect at the point 1326. Our therefore statement would read, therefore, Malcolm is 26 and Stephen is 13. Three times as many robins as cardinals visited a bird feeder. If a total of 20 robins and cardinals visited the feeder, how many of each bird were there? Well, we need to start with a declaration. We've got robins and cardinals. We want to know how much of each or how many of each there are. So let's say that R is the number of robins and C is the number of cardinals. And we have our first statement that says 3 times as many robins as cardinals visit a bird feeder. We could represent this particular fact with the equation of R equals 3C. 3 times as many robins as cardinals visit a bird feeder. Imagine there were 3 robins. 3 robins would equal 3 times the number of cardinals. Our second statement says that the total number of robins and cardinals is 20. We can represent this statement with the phrase or the equation C plus R equals 20. So now we have 2 equations. However, one of our equations, this one right here, is not in slope-intercept form. So we need to rewrite that as R equals negative C plus 20. Now we have 2 equations in slope-intercept form. We could set them equal to one another. 3C equals negative C plus 20. Collect all our variable terms on one side and our numbers on the other and solve for C. And we arrive at a value of 5 for C. Once we have a value for C, we can plug that value into one of the equations and solve for the other variable. So we'll use that first variable and we'll plug in the value of 5 for C. R equals 3 times 5, which equals 15. So a value of C, value of 5 for C, and a value of 15 for R. Therefore, there are 15 robins and 5 cardinals at the bird feeder. And again, if we decided to graph these 2 equations, we could see that the lines meet at the point 15, 5.